if I want to look through these and give them the name, I mean, these are all triangles, but if I want to name them, identify which ones are equilateral, which ones are isosceles, and which ones are scalene, and also identify which ones are right triangles. These are two separate things. First, I'm going to go through and look to see which ones are equilateral, isosceles, or scalene, because this just talks about the side lengths. So this first example, this one's scalene, because all three sides are different lengths. This one, all three sides are the same length, which means it's equilateral. This one, we have two sides being the same length, so it means it's isosceles. Here we have two sides being the same length, so it's isosceles. This one, we have two angles that are 60-degree angles, which means the third angle would also have to be 60 degrees because they have to sum up to 180. And we've seen that when we have three 60-degree angles, this is actually an equilateral triangle. Alright, on this one we have all three sides being different lengths. That means it's scalene. Alright, so we've gone through and identified which ones are equilateral, isosceles, or scalene. Now let's figure out which ones are right triangles. This first one right here, this is a right triangle, because you can see there's a 90-degree angle right there. This one, we know all three angles are 60-degree angles because it's an equilateral triangle, so it's not a right triangle. This one, I'm going to go ahead and guess that it's not a right triangle. None of those look like a 90-degree angle, although we haven't really seen how to truly verify that they're not. On D, we have a 45 and a 45-degree angle. That sums up to 90 so far. So that means the remaining angle would have to be 90 degrees so that all three of them would sum up to 180, which means this one is a right triangle. Equilateral triangles are never right triangles, so that one's not a right triangle. And this one, again, it's kind of hard to tell if it's a right triangle. Really, I would want to use the Pythagorean theorem, which we haven't technically seen in this class, but it's going to bother me if I say that that's not a right triangle without verifying it, so I'm going to go ahead and check. So the Pythagorean theorem, which we're about to see anyway, says if we square this side and we add it to the square of this side, on a right triangle, the square of the two legs, the sum of the square of the two legs is equal to the square of the hypotenuse. A squared plus b squared equals c squared is usually how it's said, though, because saying all that in words is cumbersome. So 6 squared, which is 36, 9 squared is 81. If that sum is the same as 13 squared, which it's not, if it was, then that would indicate that this is a right triangle. However, it's not the same as 13 squared, which means that's not a right triangle. So the only two right triangles we had here were A and D.